האורח שלנו היום הוא פאולו מטאוצי, שהוא שותף במשרד זהה חדיד, והוא יציג לנו בניין אחד שהוא היה מעורב בו מאוד חזק, מלון מורפאוס במקאו, בניין באמת מדהים, ואחר כך נשאל אותו את השאלות.
Good morning, everyone. Good morning. So, thank you for the welcoming introduction, and thank you for inviting me today to present to you our Morpheus Hotel in Macau. This is a building I've been working on for many years between 2012 and 2018 as a facade director. Even before starting, I think that I have to thank the entire team, Zaha Hadid Architects team, that has been working in a very passionate way on this building over those years, from our Hong Kong office and mostly from our headquarters in London. Of course, a special thanks has to go to Dame Zaha Hadid, our founder. Zaha's contribution to the world of architecture is of paramount importance, I guess, and it has been recognized with a Pritzker Prize in 2004 and later on by a golden medal in 2016. Since she founded the practice back in 1979, we grew up significantly in a very niche market, I would say, thanks to her extraordinary vision and original approach to architecture and overall to the built environment. So we grew up, we are now 450 architects working from London, from Beijing, from Hong Kong, from New York, and we work worldwide. So we have projects in Europe, projects in Middle East, in Asia, in Americas. We recently expanded our business in Australia as well, where we are designing the West Sydney Airport. So overall, in the past 40 years of our activities, we have built more than 66 buildings in almost 20 different countries, and we have more than 50 projects up and running under design development. So this is our latest delivered, completed project in Beijing, is the Beijing Air Terminal. I think it's the biggest in Asia. Someone says the biggest in the world. I didn't check that, but his C-star shape has been thought to optimize, because of the big size of the terminal, the passengers' movement inside of the building. The mega roof is supported by 6 concave columns, which are supporting the roof itself and also hosting the 6 elliptical skylights, which are bringing natural light inside of the building. This is again a building that we completed a couple of weeks ago, again in Beijing, and it's a set of twin towers which are hosting a super tall atrium which reaches the top of the building, so it grows up from the ground floor to 200 meters in height. Probably we are best known for our cultural landmarks, such as the Contemporary Art Museum in Rome. This is the first building I've been working on when I first joined Zaha back in 2002, or our cultural center in Azerbaijan. Overall, we do residential development, we do mixed use, we do master planning. Let's say that our activity around architecture and our activity around urban design and master planning is supported and driven by our internal research. So overall, our research is in the data-driven design. So we recently opened several additional departments which are producing research inside of the company, such as the environmental analytics, the computational design, and the space planning department. Probably we are best best known for our research in parametric design. So we have been pioneering this specific research in this sector over the past 10 years. And I would say that the Macau Hotel Tower is probably the highest point of our research on parametric design. This is an animation that didn't start. So just to give you a glimpse, just to give you a glimpse of the building. This is a movie that we shooted just a few weeks after completion. It's the tallest structural exoskeleton ever built. It's a gigantic structural cage that supports the building from outside of the glazing. The video picks the major feature of the building, so the super tall internal atrium with the panoramic lift, the bridges with the restaurants and the shared facilities, the art galleries, and then the swimming pool at the very top of the building. Overall, the building behaves like it's a big landmark for sure, but it's also a sort of a urban embroidery. So it's a precious decoration in the urban landscape. So I decided to upload these few slides just to give you, for those of you who are not familiar with Macau, an idea where we are. So we are in the southeast coast of China, just opposite to Shenzhen and Hong Kong, on the Pearl River Delta. So there are different ways and different systems you can use to reach Macau. So you can land there with your flight, or you can land with helicopter. You have two ferries terminal. You can now also drive directly from Hong Kong to Macau. They just completed a gigantic system of underwater tunnels, 4 cable bridges, 3 artificial islands that are allowing you to drive directly from Hong Kong through the delta of the river, reaching directly Macau. But whatever system you will use to get to Macau, you will have to pass through the City of Dreams district. So, as you know, the Kotai Island hosts one of the biggest agglomeration of entertainment and amusement park and casino and hotel. Is the Las Vegas of Asia somehow. And the building, the Morpheus, it's just at the beginning of this urban system. So the strip that crosses north-south the Kotai Island starts effectively with the City of Dreams. So the hotel we were asked to build had 2 specific roles. So one is the being a portal, so a welcoming entrance to the urban system of the Kotai Strip, but at the same time is the portal and the entrance to the City of Dream. So this was the idea behind the shape of the building itself, that reminds the idea of a gateway to the urban system and to the system of the City of Dreams. So our building is the one marked with a red dot on the screen, and it gets connected to an existing podium where the casino and the retail loop, which is the green loop you see at the ground floor, connects the 4 existing hotel towers. So the Grand Hyatt, the Rock Hotel, and the Crown Hotel are connected through this system. Just to give you a glimpse of what is happening along this commercial strip, this ring at the ground floor. So, of course, there are halls, entrances, and banqueting hall, food court. There's entertainment, so there's a gigantic water theater. There are pop-up shops and special kiosks happening around. So our idea for the building was not to break the continuity of this loop. So what we literally did is that if this is the ring of the existing commercial group, what we did is that we rotated vertically and we connected and we plugged it to the existing circulation so that people could move all around that can loop up into the building and going down on the second core, entering again into the system. So without breaking the experience of the existing gallery. Of course, while you are looping vertically through the building, you can also access in several points to the internal part of the building. So there are bridges and mezzanine which are cantilevering inside of the central space. Overall, you have a set of twin cores facing each other and an activator, which is the central space included between the two cores, where the bridges and the mezzanine are cantilevering inside. So we have about 780 rooms, which are marked in green on the two twin towers. There's a commercial podium in blue at the bottom, and there are sky villas at the top just around the casino. And in dark green, you can see the bridges and these shared facilities and the public facilities which are connecting the set of the two towers. So let's have a quick journey. So today's presentation is divided pretty much in two parts. The first part is a sort of an architectural overview of the building, while the second part we will go a little bit more deeper in the detail of the building and how we made it, how we did it. So let's start from the drop-off area. So you arrive with your car in the sheltered area of the drop-off, and you enter into the main lobby. You can recognize here the two cores facing each other with the 6+6 panoramic lift, which are leading you directly from the ground floor to the swimming pool at the very top of the building. So we start our journey. We get on one of the panoramic lift. We leave the lobby at the bottom, and we reach level 21, where we have the first bridge connecting the two cores, where the Chinese restaurant is. So for this restaurant, we also designed the fitting out of the tables. So this sort of shell, which is embracing the tables and is flexible, so you can expand it and reducing it, so that you can host a smaller table or a group of people. So from 5 in a row to 3 in a row. This is because in China and in Asia, people like to have this kind of more private environment when having their dinner with their friends or with their relatives. So we leave now the level 21 and we keep on raising with our panoramic lift. So we are looking down to the restaurant, and looking up you already see the bridge of the upper floor spanning again between the two cores. So this is the faceted cladding of the ceiling of the restaurant, and this is level 30, where the lounge and the breakfast tables are again carved into the central space of the building. We keep on raising with our lift. We leave level 30 and we reach the upper lobby, which is at the top of the mega atrium, where the entrances to the sky villas are. So this is the highest point of our internal atrium. Again, at the top, you can recognize the ceiling. This is the bottom of the swimming pool at the very last floor. So you end your journey up to the top of the building in the swimming pool. The water of the swimming pool has been extended all across the building from the north to the south facade, so that we receive light not only from the central courtyard, but also from the south facade, so you can enjoy a nice sunset, and the light inside of this area is becoming particularly beautiful early in the morning and late in the evening. You can also swim through this gigantic structural element, which is also another a beautiful experience at this point of your journey. And then you take the second core. You take the lift going down on the west side, and you find a number of smaller areas, mezzanine, which are only partially cantilevering and protruding inside of the central space. This is the art gallery that could be rented for special and private events. And then this is again another video which I shooted with my iPhone. Yeah, the day of the opening. So from the gallery, again with your lift, you go down, and it's interesting to see how the inside-out effect of the panoramic lift is behaving. So you always have the perception of the inside and outside of the building, always while you're moving vertically through it. And you land again in the main lobby. So this is the day of the opening of the building. They have unveiled the atrium, and they played a sort of a vertical concert. So the idea of the entrance lobby is that this is also an entertainment space, so it's a space for event. The panoramic lift gets stuck at this point. The doors of the lift becomes lighting element, and you can have performers or musicians, and this is becoming a big show, and you're in the center of it because you're surrounded by the lift. We also designed this small pavilion inside of the main lobby for Pierre Hermé, the famous 3-star Michelin chef, and he designed his own line for the Morpheus, which is customized and inspired by the faceted facade and the mesh of our inside and outside design approach to the building. So the interior of the building reflects somehow the geometry of the facade, and the idea is to provide a sort of an holistic approach to the experience of the building. So let's have a look now at the technical aspect, let's say. So just to give you a better understanding, I know that most of you are either architect or engineer, and hopefully I'm not going too much in detail for those of you who are not that familiar with technical aspect, but I think it's important to understand how this building behaves structurally and technologically. So we have 3 main components. We already mentioned about the 2 cores of the building that you see on the left in pink. The central part is the sealed envelope of the building. So this is the glazing facade. This is what ensures the building to be a building, because effectively it sealed the space. And then you have the structural exoskeleton, which is the cage outside of the building that you see here on the right side of the images. So basically all the beams are spanning between the core directly to the outer structure, passing through the glazing with a number of penetrations. So all the nodes of the exoskeleton have been aligned to the slabs that you see marked with red dots on the right side of the image, and on the left you see the detail. So this is the penetration of the beam passing through the facade and reaching the outer exoskeleton. Of course, only the nodes are not enough, so whenever a member is crossing the slab, this establishes a structural connection to the building itself. So each time you have a different penetration of beams spanning from core to the exoskeleton. This is ensuring and those are all the penetration. There are 100 of different penetrations through the building. This is just a small table showing the different conditions. Basically, this is allowing us to reach a completely column-free space. So each floor is absolutely column-free, so ensuring the maximum flexibility, and you can really enjoy the space because the structure is completely either outside or inside toward the cores. Overall, the exoskeleton and the cores, they work together not only because they bring the vertical loads down to the foundation, but also and mostly because it reacts to horizontal forces. So basically the connection that has been established between the exoskeleton and the cores is ensuring the building to give a proper answer to the horizontal forces received by earthquakes. And those are some slides from the construction site. So you can recognize the twin cores, which are growing and with few days of differences. You can see the slabs and the exoskeleton following and wrapping, literally wrapping the 2 cores, and some close-up in the same phase of construction. So this is where we were at the end of schematic design. So the engineers came back to us, they analyzed the exoskeleton, and they gave us all the structural profiles to ensure that all the loads were properly transferred. But they also gave us a bad news, that the central belly, the central part of the building, the structural component was simply gigantic. They were almost obstructing the view from our platform and the view from our bridges. So at the end of schematic design, we went through optimization of the structural internal part of the building. So we analyzed the central part, the bottom up, starting from the ground floor up to the roof. And I will give you now an idea on which are the most important structural components that finally help this building to perform the way it's performing at the moment. So we extended the column of the atrium to reach the glazing, so the bottom part of the belly. We branched the columns to reach the nodes of the skylight. And as you can see here, the zigzagging of the facade here. Can you see the mouse? Yes. This is following the branching of the column. As you can see, they point toward the nodes of the skylight. So here the skylight is effectively spanning from north to south, supported directly by the branching columns. Going ahead, the other problem we had is that all the slabs were entirely supported by the exoskeleton. So we have a very big load that the exoskeleton had to support in the central part. So we downloaded part of this load by introducing trusses spanning again from core to core. And basically in this area the exoskeleton is providing the horizontal stability and picks the load of the 4 triangles which are left out from the typical sand wall shape of the bridge at this floor. And then we came to another solution for the entire central part, so we call it the stitching. So we reach the node all around the boundary of the central area, every other floors, with internal propping columns. So you can see these diagonals here, which are again spanning from the core toward the node of the facade. So this is ensuring that every other nodes, the loads are carrying down through the diagonal directly to the 2 cores of the building. In this way, we have created a very interesting feature because the faceted design of the internal walls is a characteristic of the building, but at the same time is the structural answer to support the central belly. And here on the left, you can see the diagonals, which are supporting the exoskeleton every other floor. And this is the faceted internal facade on the art gallery. The last 2 components are at the very top of the building. So there we had a gigantic load because we had a swimming pool. And the swimming pool is in between the 2 cores. So we had to span with a big truss, which is the one you see here. So this is a 9 meters high truss spanning from core to core to support the load of the swimming pool at this level. At the bottom of this truss, there is a second one, which is instead again supporting the belly. So basically from this second truss that you see diagonally there, you have those stubs which are hangers to the exoskeleton and to the facade at the bottom. So the facade gets completely supported all around its own perimeter. So we ended up this phase with a completely revised structure of the exoskeleton. We gain the proper structural profiles for the central belly, ensuring the view from our platform and the view from the terraces. The second problem we had was about the geometry. So as you can imagine, because of the free form of the exoskeleton in the central part, what happens is that all the structural members were twisting. And a structural twisting member doesn't perform well. So we had to reduce the structural profile to be fully planar. So each structural profile has been constrained in a single plane and has been singly curved. So it's bended in one direction only. So we identified all those planes, basically, which are identifying the axis of all the structural components. By doing so, we ensure that all the forces which are crossing into the nodes are transferred through vertical and flat planes. Because the members are reaching the node with different rotation, of course we had to manage the depth of the node which was receiving the member itself. And all those parameters that now I just had to list very quickly, and some of them might have not been clear in full, I mentioned because the point is that this, as I was saying at the beginning, this is a parametrically controlled building, so all those data have been brought into our algorithm, have been managed through the algorithm itself, and all the components have been baked out of the algorithm to be rebuilt on top of the shape of the massing that we generated. So all the planes have been extracted from the algorithm, all the nodes and all the members with all the dimensions, proportion, rotational angle, curvature have been calculated directly by the algorithm. We calculated also the structural volume of the structural components, meaning that we ensured that whatever the engineers would have done, they would have done it inside of this red box, while we were working in parallel on the aluminum cladding on the outer part of the building. And those are some images from the side, so you can recognize the member getting to the node rotated, and some polishing of the nodes, also the proportion of the node in the space. They were really gigantic. And again, some images of them during construction and before cladding. So overall, the cladding is following the exoskeleton. It tapers, so that is lighter at the top and is wider at the bottom, exactly as the structural component are doing. So the cladding as well is following the same rule, just not to be too heavy at the top. Everything has been brought to the wind tunnel test to control the pressure of the wind on the outer part of the cladding. And the result of these calculations have been then plugged into the beam model of the facade. So every single plate, every single stiffener and bolt, everything has been calculated through other algorithms that have extracted the secondary component. This is what you will never see of this building because this is behind the aluminum panels. But everything has been designed in 3D and directly fabricated. And this is the result. So we took the panels, we brought it on our visual mock-up. We checked the consistency of the tolerances. So through this parametric control, we managed to control the tolerances of the building in the range of the plus minus 2 millimeters. So everything has been very, very accurate in the way it has been designed and then further manufactured and installed on site. And now just to close, very quickly through the fabrication process of the facade components. So the outer part of the aluminum cladding is still a doubly curved surface. So we had to create molds, which you can see here on the floor in aluminum plates. And then we cut the aluminum panels, the flat sheet. We pre-bend the aluminum panel, and then we weld it on top of the formwork. We then use the CNC cutter to refine the edges of the aluminum, which is now a three-dimensional component. And then we check all the tolerances and the dimensions have been properly taken. We start the production of the frame to support the aluminum cladding, and we weld it at the back of the aluminum panels. We remove then the formwork, which is this element here. We pre-assemble everything in the factory just to be sure that all the components are properly fitting and matching, so not to have surprise when you enter on site. We then dismantle everything, we coat the panels, and we bring them on site. We test them on the visual mock-up, and then in the final construction site. And those are the images of the work in progress of the aluminum cladding in this area of the facade. And the final results, so the single curved area, the flat area of the facade, the transition toward the central belly, and then the most complex part of the building, which is the internal atrium cladding facade. If you're not too tired, I will give you also a glimpse on the glazing, just to let you know how it works. So basically, the internal mesh has been subdivided in macro components that we call macro windows. So basically, on the projection of the outer exoskeleton, we literally trim a rigid component, which is basically the macro window itself. Those are the macro windows in 3D. You can recognize the stubs. Those are the connections toward the exoskeleton. So the exoskeleton is supporting the macro windows. Everything has been checked again in the BIM model, so in a full three-dimensional environment, of course. And the way it works is very simple. So basically, if this is your macro window, you hang it from the top, right, this way. Then you put it in the right position, and then you hold it back at the bottom. So each macro window is supported in 4 points, exactly with this principle, and they're all independent one from the other, and they're all separated by movement joints. And this is the rigid component of the single window that has been fabricated, again brought on site, and put in the right position in the space, supported by the exoskeleton. This is the same image that you've seen at the beginning, the one with the faceted ceiling and the bridge spanning with the macro window at the bottom. And again, the final images from the site. The opening that you see here are the maintenance hatches. So basically from inside you can easily open those triangles and you can access to the facade for general maintenance, cleaning, replacement and so on. And those are just some close-up on the internal part. So overall this is the completion of the building, and I will leave you just with a final video that summarizes what we just went through. So all the 3D data that has been used and the way we did it. There should be a sound as well, but it's not coming. Never mind. Yeah. So the visual mock-up. And the idea of the video is to put together the real images of the building, such as this one and this one, with some work in progress and some glimpse from our design activities, but also the fabrication of the components. So those are the megastructural element of the exoskeleton, the erection of the twin cores, and the erection of the exoskeleton itself. The macro windows, and the final structural elements. The fabrication of the aluminum cladding, the bending of the framing, the pre-assembled phase, and then the coating. Then the coated panel get packaged and transported on site. What is a combination of technology, innovation, and craftsmanship. And this is the top up of the building, so that's the last structural component of the exoskeleton put in place. After this one, we had a gigantic party, as you can imagine, so we all joined on site and celebrate this moment. And thank you.
Really beautiful. And it was started, the design was started while Zaha Hadid was still alive?
Yes, actually this is the last building she attended the opening to.
Oh,
so
really?
yeah, so it's the late Zaha Hadid, we can say. Yeah, she was alive all the
because it has something different to me, to my eyes. It's very Gothic, you know, like a Gothic cathedral. And also the craftsmanship and every piece and the fact that the construction is from out to in is, and also some of the symmetries are also almost Baroque, you know, in the cultural side of the architecture, you know, it's innovative, but at the same time it's very much part of a long legacy of great architecture.
Yeah, I mean, you're perfectly right, and of course, as always, there are several reasons for coming to a massing for a building. And in this case, we've been asked to provide a very high level of efficiency. So overall, we had to somehow comply with a given brief, which was including the request from the client of creating a very, very iconic building. So it's like when a client comes to you, and this is happening in our company. I think that I feel lucky for that, because we have clients that are simply coming saying, we would like you to make our dreams come true. So they're not giving you directly a budget or a need or a function. They say, we want a vision here. But of course, we
very
also...
lucky for you.
Yes. I know. It's very beautiful. Yeah. And okay, so we've been constrained by the brief for sure. So it was ambitious. We had a lot of rooms to plug in an ambitious massing. And we've been constrained also by the foundations, because the client, before coming to us, had to drop a previous scheme for the same plot. And we had several foundations already in place that we had to deal with. So the shape of the plot was, you know, surrounded by existing building. You've seen it. It's a rectangular, very small plot with existing foundation in there. So the idea of growing with two symmetrical cores came also because of the analysis of the existing foundation. So the two things together brought us to the idea that the iconic part of this building should have been on the facade. We had to do something really extraordinary on the facade and not on the massing itself.
Yeah, that's how it looks.
Yes, that's exactly what we've done. So.
Tell me, when Zaha Hadid died, I think that everybody anticipated that it would be a sort of end to the line, because it's so personal, it's so based on her talent and her vision, and things that are very individual. And but you continued. Your firm is bigger now by 25% at least of the people, and you do beautiful things. So how did it happen? How did it happen that such a distinct talent goes on to in the heritage?
Well, because I think that we, Zaha and we, have always been working as a Zaha Hadid Architects. So when she founded her practice, of course, she did it on her own vision and her own approach on architecture. But this has been a sort of a mindset that she gave to the company. And we've always been working as in groups with a lot of autonomy, leading our own projects, and having recurrent meeting with Zaha, but also recurrent meeting with our team, and working as a, you know, in group, is a team group at the end. It has always been like that. Then of course Zaha was, you know, at the head of the company, and she had the original vision, and she gave the original input to the company. But we were already working in parallel on that. And when she passed away, we had the same concern, of course. We thought, okay, everybody sees Zaha, they don't know that we are here, and that we are all together, 400 people working in parallel, you know, and doing this design. So will our clients understand that? What it will be? Right? It's been a gigantic surprise for us, of course, when she died. It was completely unexpected. And we started receiving a gigantic number of letters from all our clients saying that they felt proud of being part of our family, and they thought that what they were doing with us as a Zaha Hadid Architect was something unique. And we understood that the perception that the client had from outside wasn't really the one of a one-person company, but was the company itself that was producing the design. And you know, with this strength, we are now carrying the legacy forward, and we keep on growing, and we keep on doing the architecture under the same vision.
So there was an upbringing, you think, from the time you are there? You, for instance, joined...
I joined in 2002.
2002.
So
And you felt that there was an upbringing to this teamwork of something which is so unique and special, because it demands some kind of an upbringing for a team to be able to go on with the same ideas and the same, because it's really based on talent. It's really based on something which is very personal. How did the upbringing go on with it, that you have this?
Well, I told you, we do research inside of the company. So basically, we, you know, when you select a concept, so what we do is that we have a team. We ask the team to come out with ideas. So we keep on hiring very young people, and we ask them. We select them, of course, and we ask them, how do you see it? How do you envisage the space, and how do you envisage the massing of this building? They came with proposals, and you know, either you recognize between those proposals something that can be carried forward not only for this project, but could become a line of research. Maybe this is something that the guy or the person that is presenting this sketch is not really aware of yet, but you can recognize something in that, and this is how we start our research, and this is how the exoskeleton is a research we are working on. I don't know, back 10, 15 years ago. So we are working with exoskeleton. Structural components which are outside of the sealed envelope of the building. And this is a research that is going on and on. It's quite recurrent in our company, as well as the fluidity. No? So this idea of very soft shape. This is another line of research that we have. So there are lines of research which are coming from the past, and we have new lines of research which are starting now. And this is giving the continuity. This is giving the continuity to our design approach, and is also bringing each time something new.
Are the construction engineers working in the firm, or are they external?
No. We're just architects. We hired directly our consultants or our engineers, or the clients hired them under our recommendation. So we usually,
because this is really what you showed us is really a mixed work of
yes, of course. This is
engineering and
the
architecture.
engineering firm here is Bureau Appold, and Bureau Appold, Arup, KPMG, all this big group are group that we are used to work with, and they have their own Zaha Hadid team. Mm-hmm. So when we knock at their door, they know that they have to mobilize a certain time of engineer. Not we cannot take on board any
otherwise it
with this kind of
it's possible.
So they have the Zaha Hadid team. That's fantastic for us.
Now Zaha Hadid started basically as almost a painter. I mean, her sketches or her paintings were before she even started to build anything. Are you still doing that?
Okay, let me tell you something. Zaha would have very badly reacted to this question because it was a recurrent question. She didn't consider herself as an artist or as a painter at all. She considered she was actually a great architect, and also had she studied mathematics as well.
Oh, okay.
So she has 2 degrees. And what Zaha did, the painting and all this initial vision, is that she understood that the tools were fundamental to express a new vision of the space. So the fact that she was somehow using the avant-garde of the end of the last century, so the constructivist and the supremacist, she thought that there was something there that could have expressed the space in a completely different manner. And the tool you use to express the space helped the transformation that she was looking for. So if you think about the use of software and computer in architectural design, we didn't change the architecture, but we changed the tool that we are using to generate the architecture. So she understood that even before entering in the era of the software and the era of the computer. So she decided that she didn't want to design her buildings with a pencil or with a pen, but with something completely different, because she had a different vision of architecture. And that was the revolutionary approach that she brought, and that's why the firm, this is also why the firm is keep on doing, I hope, great design, because we have this in mind. Tools are at the starting point of any research in the vision of the space.
Okay. Well, I think that maybe some people here have also questions for you, so please. מישהו רוצה לשאול? באנגלית, עם תרגום?
Okay, I'll use English.
Thank you.
I'm Michal Rom, architect, and it's fantastic what you're doing, of course. Everybody here is amazed. My question is, do you continue to seek for new tools like you described, of software and expression of architecture by using structural interpretation of your ideas? Do you research do you envision new technologies that you can use in the future?
Well, envisage is difficult to say, but for sure we are keep on researching. As I was mentioning at the beginning of the presentation, we have new departments which are growing inside of the company. The data-driven design, for sure, is let's say the linking element of all our research. So we use data, we use computational data to generate our shapes. And overall, we are a multi-platform company, so we do not constrain our team to work with a software or with another. If anyone literally has, knowledge of some new tools and something that could be helpful to generate something different, we are always very happy to have a look at it, analyze it, test the potentials, and in case plug it inside of our workflow. So we are really open-minded to whatever is new, whatever is innovation, and whatever is smart. This is another key word that is now, entering in our vocabulary as well as entered already in our vocabulary. So yes, so for sure we are fully open. But if you close this part, you cannot really innovate. So everything is moving so fast and so quickly that you can really keep on feeding your teams with new tools and with innovation.
Please, I'm Ghada, architect and interior designer. So I want you to ask about if there is some of the buildings that she already designed, that it's really on, you couldn't do it, or everything she designed, it's already in, you do it, you build it. All the designs that on the architect that she did you all of them build it? Or there is some of them?
We have a lot of unbuilt. So basically, we also made an exhibition of our unbuilt project.
But why? I need to tell me why. Because you can't do it because there is something you.
No, just because. Okay, sometimes because and anyone has a practice knows that project can start, but they might stop at a certain point, and this could be due to many different reasons. So some of them are coming because basically we couldn't go ahead, maybe the client changed his mind or economical condition changed or things like that. But mostly it's because just to see this building here, to come to this building and this massing, we have to generate a huge number of options. So we ask our team to work in parallel with 4, 5, 6 options, and we go ahead as much as we can with the 6 options in parallel, and we slowly select and pick the best from each of them, and then we come with the final object that you see now on the screen. And this is leaving behind a lot of tests, a lot of very beautiful research that just die at the concept level, and so. All this is there, is in our archive. We do exhibitions on this part of our work. And Zaha also opened the Zaha Hadid Design, which is our sister company that somehow uses this research maybe to produce product design or furniture. So there are research that maybe are not leading to the final building that can be successfully used to do something else, something different, something that can be produced in a few weeks rather than in many years. And this is also part of the strategy. So design is really an holistic approach for us. It doesn't have a proper scale at the beginning. The interiors, the few interiors that you have seen have been done by us. We do not design the full interiors of a building of that scale usually. The clients usually have their own interior designers. So we did the mini suite in this case, we did the atrium, the restaurants. So many public areas are usually designed by Zaha because we want to give a complete experience to customers. But when you enter in the smaller rooms or standard bedrooms, usually clients go with other designers, and we work in team with them.
Hi, how are you? I'm Clara. I've got a serious question. When I saw this building, the last you showed us, I remember, I'm an old lady, the terror attack in New York to the Twin Towers. There was an internal construction, an internal structure, and an external structure. And this is the same case. When you are planning structures of buildings, are you planning this and taking care of terror attacks? Because in that case, we had a plane that go inside a building, and because of that, are you getting this stuff? Are you thinking about it when you're planning structure like this last building you showed us?
Okay, first of all, I'm not 100% sure that the Twin Towers had an exoskeleton. I think that the structural elements were facade. Yeah, but was supporting the facade, right? I'm not 100% sure that it was. Yeah, but anyway, yes. I mean, it's a shared research. This one for sure. I mean, no. So we consider whatever is in the code and in the regulations regarding structure. So, of course, in this area of the world, you have typhoon, which have to be considered. You have high level of earthquakes, which have to be considered. You consider a terroristic attack usually when you design the ground floor, because you have to prevent cars maybe to crash against the facade of the building, but I don't think that you can have a code against airplane to crash on a tower, because this would this is not something that you can put in a code, because you couldn't build anything at the end, you know. So this is such an extraordinary event that usually codes cannot take into consideration, unfortunately.
אוקיי, תודה רבה. תודה רבה. Thank you very much.